Hello everyone, welcome to Exam Essentials. This is Fahim, and today we'll be solving the paper from November 2024 of Chemistry Edexcel IGCSE Paper 2. So without wasting any more time, let's just get into it. Okay, so the first question says that the table shows the composition of 5 species that are either atoms or ions. Okay, now what basically is the difference between an atom and an ion? So basically, whenever you have an atom, they have the same number of protons plus electron. Whenever you have an atom, they have the same number of protons plus electrons. And give me a moment, sorry for it. And whenever you have ions, the number of protons is not equivalent to the number of electrons. So basically, a proton so whenever you have an ion, the number of proton is not equivalent to the number of electron. Moving on, um, use the table to answer each of the following questions. It says that you may use each letter once, more than once, or not at all. Give the letter of species that is a negative ion. Now, for something to be a negative ion, now for something, sorry for that. Now, for something to be a negative ion, the, sorry for that, for some, so for something to be a negative ion, the number of electrons needs to be greater than the number of protons. So we basically know that electrons are going to carry a negative charge and protons are going to carry a positive charge. Now, when you have greater number of electrons, it would mean that the quantity of that negative charge is going to be greater, and as a result, the overall charge of that element or something like that is going to be negative, right? And whenever something is going to be negative, it is what we refer to as a negative ion, or another name for this is anion. So which has greater number, they have same number of electrons, so number of electrons over here is greater than the number of protons, so this is going to be D. See, this is going to be D. Now, give a letter of the species that has a full outer shell of electrons. Okay, so whenever there is gonna letter of species that has a full outer shell of electron. Okay, so whenever there is gonna be a full outer shell of electron. Okay, so let's just take a look at it. So if I write the electronic configuration of this is gonna be 2, 8, 3. So total of 13. And over here, this is gonna be 2, 8. And we know that the maximum number of electrons that a shell can hold is 8, right? To be stable or to have a noble gas configuration. Now, well, this is not the case, but yeah, for your IGCSE level, you just need to know that whenever something has 8 electron, it represents a full outer shell, though the outer shell could have more electrons, but for IGCSE levels, up to 8 is going to be okay. So answer is going to be D. Give the letter of the species that has an atomic number that is equal to the mass number. So how do you even figure this out, right? So to do this, you have to know a formula. But first of all, what basically is the atomic number, okay? So the atomic number is the number of protons or positive charge. So for an instance, sodium, 11, 23, right? So this is either you could say that this is the proton number or this is the atomic number. And this top one is the mass number. Now there's a formula that is mass equals to proton plus neutron number, right? Now you have to plug all of the values for the species in the formula and figure out the number of figure out the number. Well, let me just take a look. Which give the letter of species that has an atomic number equal to the mass number. Okay, so yeah, you have to figure out the mass number, and once you have the mass number, then you're gonna just take a look into the table and figure out the values. Okay, so yeah, that's what I have done over here. So mass number equals to number of protons plus the number of neutrons. So let's just try to calculate protons, neutrons, total of 1. Okay, so 1 plus 0 is equivalent to 1 is the mass number, and this is the atomic number as well. So atomic number is 1, mass number is 1, so A is gonna be the ultimate answer to it. So yeah, A. So pretty good question. So moving on to the next part of it, explain why species B and C are atoms of the same element with identical chemical properties. Okay, now whenever they say that something has this thing identical chemical properties, one thing should be popping out into your minds instantaneously, that it is about the it is uh, it is going to be about the electrons. So whenever there's a question related to chemical properties, the first thing that should be popping out into your mind is the electrons, cause the electrons are the species that takes part in a chemical reaction. These are the only species that takes part in chemical reaction. In chemical reactions. Okay, and what you said, that is explain why B and C. Okay, so B and C, let's just take a look at the number of electrons. Okay, so they have the same number of electrons, and hence they do have similar chemical properties as well. But see, I think that they have different number of neutrons, which means that B and C are isotopes, and isotopes do have similar chemical properties due to the same number of electrons. B and C are isotopes, and as a result, they have similar chemical. They have as they have same number of protons but different number of neutrons. Also, they have same number of electrons and hence they have identical chemical properties. So yeah, moving on to the next part. It says that a proton has a mass of this, a neutron has a mass of this. Calculate the mass in grams of the nucleus of an atom for species C. So a really easy and basic math. So a nucleus is what? A nucleus is basically the center of an atom, right? And inside the nucleus, we have both the protons and neutrons, and the both are sticking together in the nucleus, or you could say that they could be found inside the nucleus. Now, what you're going to do is, this is the mass for one proton, right? So suppose there are x protons, right? So you multiply that with x, and this is the number of uh, mass of the number of neutron, right? So and suppose there are x neutrons, so you multiply this with x. Then what you do is you add this with that, so you have the total weight, or what you could say the total mass of the nucleus, right? So for C, um the number of proton is this and neutron is this, so 9 times the mass of this and 10 times the mass of the, let me just check, either that is uh okay, yeah, for, wait, was it C or D? For C, okay, so for C, protons 3 times that, 4 times that. Sorry, I was speaking about C, but it should be D. Sorry, I was speaking about D, but this should be C. So yeah, moving on. That's what basically I have written. Mass, this plus this, hence this, and wait, it said about species C. Uh, I feel like I did about species D. Okay, so it basically said about species C, but I did the opposite thing. Sorry for that, everyone. Let me just correct this quick. So 3 and so 3 and 4. Okay, so 3 and 4. This should be 3 and this should be 4. Let me just check. 3 times 1.6726 into 10 to the power minus 24 plus 4 times 1.6740 times 10 to the power minus 24. This should be equivalent to 1.1713 into 10 to the power minus 23 grams, 1.171. So yeah, this is the answer. So answer is like 1.17138 into 10 to the power minus 23. Since they didn't mention anything about significant figures or decimal places, answer giving to this is okay, way more than enough. 171.171.171 times 10 to the power minus 3. So yeah, moving on. Okay, so this question is about metals and metal compounds. Okay, all metals are malleable and good conductors of electricity. Okay, so what basically is something that is malleable, right? So whenever you hammer on this, or whenever you put a force on this, right, and try to distort it, they are going to slide over each other, right? And this property is what we refer to as malleability. So the layers of metal ions can slide over each other. Now you could say something like, sir, as they could slide over each other, right? So at some point of time, a positive ion could be next to another positive ion, and we know that they're gonna repel each other, right? As negative charges are gonna repel. But why they do not repel? Okay, so this could be a question. So the thing is that there are electrons, and this delocalized electrons prevents the repulsion between these positively charged ions, and the electrons between the metal ions prevents this repulsion. Now, explain why metals are good conductors of electricity. So this is because there are these delocalized mobile electrons that could flow and conduct electricity. So wherever there are free electrons that can move, either that is chemistry or physics, it would lead to conductivity of electricity. Moving on. That's what I've written. They have free mobile delocalized electrons that can move and as a result conduct electricity. Moving on, everyone. Now, two methods for obtaining a metal from a compound are by electrolysis or extraction using carbon. Okay. Explain without using practical details which method is gonna be most suitable for extracting iron. Okay, so whenever there's some, so by the way, the name for this is magnetite. The name for this is magnetite. So there's this Fe2O3, that is hematite, but this thing over here is magnetite. Okay, now this is the iron extraction, and basically whenever there's an iron extraction thing, we are going to use uh, those use that carbon method, right, in a blast furnace, because yeah, because um, iron is way below than carbon in the reactivity series, right? As a result, this carbon could displace this uh, iron from this ore. So yeah, we're going to use this. So extracting using carbon, this is because iron is less reactive than carbon. Okay, so these are some of the equation of it, right? These are some of the equation of it. I basically don't need to mention this in the questions, but yeah, I have done that, so that this could be like a revision for you. So basically, this thing is taking the oxygen, right? As it is taking the oxygen, it is gaining the oxygen, right? So this thing is getting oxidized, and this is gonna be the reducing agent. Whenever something gets oxidized, it is gonna be a reducing agent. Now, why basically this is a reducing agent? Cause it is reducing this iron, because the iron is losing the oxygen, right? But itself is getting oxidized, hence this thing is a reducing agent. Reduces other substances but itself gets oxidized. Moving on, a student has a solution of iron 2 sulfate and a solution of iron 3 sulfate. Okay, describe a chemical test. Iron 2 sulfate. Okay, basic one. So what you're going to do is you're going to add NaOH to the test solution, right? And whenever you add NaOH to the test solution, FeOH2 forms, which is a green precipitate, and that would confirm the presence of this Fe2 sulfate. Okay, so yeah, basic iron test. So at equal volume and concentration of NaOH to both the solutions, okay, and the solutions that have the green precipitate will be Fe2, as FeOH2 precipitate forms. Here's the reaction of it. Fe2 plus reacts with 2OH minus to form FeOH2 solid precipitate. Moving on to the next question. Okay, so a teacher uses this apparatus to separate a mixture of ethanol and water. Okay. Uh, so yeah, this is gonna be fractional distillation. Okay. Uh, Now give the name of the method used for this separation. So this is gonna be fractional distillation. Now the question is when. Now the question is when do you use a fractional distillation method and a simple distillation method, right? So basically, whenever you have two solvents that have boiling points that are close to each other, you're going to use this fractional distillation method for better separation. And whenever you have two liquids whose boiling points are relatively different, then you're going to use simple distillation. Moving on. Apparatus XYZ. Okay. X thermometer, uh, Y is the condenser, and Z is the beaker. Give a physical test that the teacher could do to find out if the ethanol produced is pure. Okay, so we know that ethanol has a boiling point around 74 degrees Celsius, right? So if the pure ethanol boils at this temperature, then we could, if the ethanol boils at this temperature, then we could confirm that the ethanol is pure. Oh, sorry for my, the ethanol boils at 78 degrees Celsius, not 74. So determine the boiling temperature of the ethanol. Pure ethanol will boil at 78 degrees Celsius, because if there are any sort of impurities or something like that, then the boiling points would gonna differ. Okay. So yeah, that's more or less that we have to know from this. Moving on.
Let me guess. You are watching videos, taking notes, maybe even grinding late at night. But the marks, they are just not going up. You are stuck, and it's frustrating. But here is the truth, it's not your fault, it's the method. And that's exactly where Exam Essentials makes the difference. We at Exam Essentials actually offer two very powerful cores to navigate you towards success. The first one is the most popular high impact crash course. If you are just 4 to 6 months away from your exam, This course is going to be a lifesaver for you. And the second course that we at Exam Essentials actually offer is the complete 1 year course. This is basically for the students who want full support from day one to exam day. And the best part, our students' results speak for themselves. Both the courses are actually open ahead of every exam session. No matter whether you are going to give your exam for the May 26, Jan 27, May 25, or October 25, doesn't matter. We always offer these two courses before every upcoming exam session. To join or know more, just check the description box below. You will find our WhatsApp number and Facebook page link right there. Let's turn your effort into results together.
Teacher adds a small piece of lithium to water and collects the gas produced. Give two observation when lithium is added to water, right? So when lithium is added to water, uh, lithium hydroxide forms, and also this hydrogen gas, right? Now, what are some of the observations? So there's going to be effervescence or bubbles due to the production of hydrogen gas. And another thing is that the piece of lithium is obviously going to get smaller. Moving on. The teacher has a few drops of universal indicator. The solution explain the final case. So let me just write the overall equation for this. So lithium reacts with water to form what? To form lithium hydroxide plus hydrogen gas. Now, basically, the solution formed over here, this thing is alkaline, and whenever universal indicator is added to it, the color change is going to be blue. Blue due to the formation of LiOH, which is an alkaline, right? Now, let's see, they have basically written the same thing over here as well. Uh, the teacher collects 500 this of hydrogen at room temperature. Calculate the mass in grams of lithium that the teacher added to water, and 1 mole of gas. This is the molar volume. And yeah, so basically this is a basic question. So what you're going to do is, first of all, you find the moles of this, right? So how do you find the mole of this? As it is a gas, number of moles is going to be volume by molar volume. Then you have your volume, this is this, and you have your molar volume as well, this is this, right? So you find the moles of it, right? Now what you're going to do is you're going to then compare the molar ratios. See, it is in a 1 to 2 ratio, right? So the moles of this is going to be equals to 2 times the moles of hydrogen, right? And uh, once you have the moles of uh, lithium, what you're going to do is n equals to mass by molar mass. So this is going to be n of lithium, mass of lithium, and you're going to plug in the value for the MR of lithium. That is, where's that? Okay, so the MR of lithium, so N of lithium, mass by MR of lithium, that is 7. So basically you make M the subject from here and you get the mass of it. So that's what I've written in short. See, moles, I found this, the molar ratio comparison. So 1 mole represents 2. Therefore, this mole is going to represent 2 times this, that is this for lithium. Therefore, mass equals to moles of lithium times MR. So this should be 0.32 gram. Moving on. The teacher adds a small piece of potassium to water. Give one exa one observe give one observation with potassium that is not seen with lithium. Okay, so it burns with a lilac flame. Lilac flame, right? So potassium is way more reactive than lithium because down the group the reactivity increases, okay? And the reactivity depends on the ease of losing electrons, okay? So down the group, as the radius increases, the force of attraction between the outer shell electron and the nucleus decreases, and hence it becomes easier to lose the electrons. Uh, So yeah, that's what I have said over here a while back. So yeah, why potassium is more reactive than lithium. So down the group, the radius increases. This is because the number of electron shells increases. Force of attraction between the nucleus and the outer shell electron decreases, and as a result, outer shell electron of potassium is lost more easily than lithium, and hence potassium is way more reactive than lithium. Moving on, guys. So this is what I was referring to, right? So see the distance. So this is way more than this distance, right? As a result, the attraction between the nucleus and the electron over here is way less than the attraction between the electron and the nucleus over here, right? And hence it is easier to lose these electrons. Now, a student does some titration to find the volume of dilute nitric acid needed to neutralize exactly this of sodium hydroxide, right? So whenever you say that something has a decimal, you have to understand that you are using a pipette for this pipette. And basically, whenever you are using pipette, you're basically trying to find the most accurate volume of it, right? Because you're basically this indirectly means that you are using the moles of these in your calculations. Step one, add this sodium hydroxide solution to a conical flux. Okay, add add 3 drops of methyl orange. Okay, so the earlier part, maybe that's not the case when you're gonna use the moles of it. But yeah, whenever there's a decimal, you're gonna use a pipette. 3 drops of methyl indicator. Okay, so this indicator, right? Whenever there's something that is acidic, it is orange, and whenever there is something basic, it is yellow. You have to memorize this. Fill burette with acid, add acid until indicator. Okay, so basically, the burette over here contains this acid, and this is the flux containing NaOH, right? So initially, the color of this indicator is gonna be yellow because of this NaOH, right? As it is basic. Now, as you keep on adding this, an acid-base reaction occurs, right? And as acid-base reaction occurs, this NaOH is gonna get used up, right? And at one point of time, all of the NaOH gets used up. So basically, you are left with no NaOH. So as you keep on adding this nitric acid, at one point of time, there is gonna be an acid. There is gonna be all acid over here, right? So after all of the sodium hydroxide gets used up, any of the droplet of that nitric acid falling over here turns the color of the indicator to red, which means that all of the NaOH has been used up. So yeah, this is the basic principle of titration. Moving on. Give the name of the apparatus that the so yeah, as I said, to one, this is obviously going to be a pipette. Color change seen in step 4 is going to be red from yellow. Give a reason why. Okay, so basically, whenever you're trying to use a universal indicator, it basically gives a range of colors, right? So the color change is not sharp enough. So does not give a sharp color change. Moving on. Okay, so this question is about some sort of a titration and the reading. So let's just take a look. Okay, so burette reading at the end, start. Okay, volume added. Rough titration, and then you're going to carry some of the titrations as well, right? This is going to be an start of the titration process, like the beginning, the first like or a sample work. At the end, at the start, so at the end, so this is going to be 23, 23.5, 6, 7, 8, 23.8. Okay, 5, 6, 7, 8, 9, 10. Yeah, 23.8 at the end, 23.8. And at the start, this is gonna be 2, 2.1, 2.2. So as this lies in the middle, this is gonna be 2.15. So 2.15. And the difference between these two is gonna be uh 23.8 minus 2.15. This should be around 21.65. Okay. Uh, okay, moving on. uh, record record the volumes. Okay, now concordant result. Okay, so whenever there's this word named as concordant, it means that the values are not gonna differ by more than 0.20. It simply means that the value differs by 0.20. Each of the values differs by 0.20. Okay, so use concordant result to calculate the mean titer. Okay, so how do you calculate the mean of something, right? So x1 plus x2 plus x3 by a1 2 3, right? So this is how you calculate the mean. So the mean titer is gonna be this thing differs by 0.20. No way. Okay, no, sorry, no, sorry for that. Plus 250. So this and this could be one. Let's just check this. No, not at all. So yeah, this is gonna be this divided by 2. See? This divided by 2. So the mean titer of that acid is gonna be 21.40. This is the volume of nitric acid though. Okay, so question 5 says that the equation for the reaction between dilute nitric acid and sodium hydroxide is this. Okay, after the titration, the volume of acid in this 25. Sodium nitrate decomposes at high temperature. Okay. Describe how the student could obtain pure dry crystals of sodium nitrate from dilute. Okay. So first of all, so as you know, the mean titer volume, right? So what you're gonna do is you're gonna repeat the experiment without the indicator, right? Then basically those basic steps of crystallizations, you're going to heat to the crystal point and then dry. You then cool the solution on the filter paper and you obtain the crystals. Okay, and dry it on the filter paper. Repeat the experiment using same this and this, but without the indicator. Obviously, heat to crystallization point and then cool it. Filter out the crystal forms and dry it on the filter paper to obtain the pure crystals for sodium nitrate. Moving on. Describe how crude oil is separated into fractions by fractional distillation. Okay. So basically, in the process of fractional distillations, what you do is you first of all heat heat the crude oil and turn it into vapors, right? And the vapors then passes into this column known as fractionating column, that is hotter at the bottom and cooler at the top. Now, substances separates on this based on their boiling points. So at the top, you have the one with lower boiling point, and at the bottom, you have the one they have the highest boiling point. So yeah, the crude oil is heated and the contents in it are vaporized. The vapor then passes into the fractionating column, warmer at the bottom, cooler at the top, condenses at different height based on their boiling points. So you could quickly do an image search on this to find an image of this fractionating column and everything. So that would make the process way more easier to digest. Moving on. Some long chain alkanes from fractional are crack. Okay, so for cracking, what you do is um, you add aluminium or silica catalyst and 600 degrees Celsius. You have to memorize this in short. Okay, so first of all, shorter chain alkanes binds um, shorter chain alkanes binds more easily than longer chain alkanes, and hence they are more demanded as fuels. Shorter chain alkanes are more useful as fuels because they burns way more easily. Okay, moving on. Reacts with bromine. Okay, this reaction is a test for bromine ions. As this test is this is a test for the presence of double bonds or unsaturated compound, because it decolorizes the bromine water. Okay, molar enthalpy. Okay, so for delta H, you have to know that BB minus BM. So bond breaking, bond making. Okay, so yeah, that is how you find molar enthalpy: bond breaking minus bond making. So these are the bonds that are being broken and these are the bonds that are being made. So how do you do this? One this one carbon carbon double bond this, so 612 plus CH 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 4 CH bond, so 4414. You do the same with this as well. Now for this one carbon bromine so one carbon bromine, you find the value of that from here, carbon bromine, hence there are two of it. Then one carbon carbon plus that, then 4 carbon hydrogen, right? So this, so yeah, in that way you would find the energy for your bond making, and also you'd find the energy for your bond breaking, so BB minus BM, and hence you'd get the value of your del H. Thus I have what I have written, bond breaking, bond making, del H equals to bond breaking minus bond making. You have to memorize this, and yeah, the value is going to be minus this kilojoule per mole, which means that the reaction is exothermic. Okay, so yeah, moving on. Explain why the reaction between ethene and bromine is exothermic. Okay, so for del H to be exothermic, BB minus BM, right? So bond making needs to be greater than bond breaking. As a result, the reaction is gonna be negative overall, right? Because this negative value is bigger than this one, right? Hence the overall value is gonna be negative, and as the result, the amount the amount of energy released during reaction is gonna be negative as well, and the reaction is classified to be exo. Energy needed to break the bond is less than energy released during bond formation. So yeah. So yeah, hence the reaction is exothermic. So del H BB minus BM. This is greater, right? So yeah, overall thing is gonna be negative as well. Moving on. This question is about alcohols and carboxylic acid. Alcohols, carboxylic acid. Okay. Name the alcohol. So this is gonna be 1, 2, 3. This is gonna be propanol. Propanol. Uh, Draw the displaced formula. So basically, it shows all of the bonds. So like this. And this represents the hydrogen, obviously. So yeah, it would look something like this. Carboxylic B has a chain of carbon atoms with no branches. The number of CH2 units is represented by the letter N. Calculate the value of N. Okay. So the this of this is okay. So how do you figure this out? Carboxylic acid B has a chain of carbon atoms with no branches. Okay. Um, okay, basic easy maths, right? So this is the total MR of it, right? So what you're gonna do is you have to use like this 15. 15 is like this entire thing, 12 plus 3, 15 plus this is what 14, right? 12 plus to 14 times x, cause this thing is going to multiply this and this thing is going to multiply this, so entire thing is going to be multiplied by this plus the MR of that, and from here you make x the subject and find the value of x. Easy. So that's what I have done over here. Moving on. Alcohol A and carboxylic acid B react together to form an ester. Give the other product of ester. Okay, so this is going to be an esterification reaction. And in the esterification reaction, there's going to be the formation of water. Moving on. Now, the structural formula of a dicarboxylic acid C and a diol is this. Okay, so this is basically nothing, right? So whenever you have this two carboxylic functional group, this is dicarboxylic acid, and whenever you have two OH group, this is a diol. Okay, The equation for the reaction between this and this is this, okay? This of uh, volume of this constant this is completely neutralized by volume of this of that acid. Okay, easy stuff, right? So what you're gonna do is you're gonna find the moles of it, then you're gonna compare the molar ratio and find the moles of it. So the moles of this is gonna be moles of NaOH divided by 2. And once you have the moles of this, so number of moles equals to volume times concentration, right? And from here you make concentration the subject, and yeah, the volume of it is given and you have the moles of it. So yeah, that's what I've done. Easy stuff. Moles of this, moles of acid, concentration of acid. So yeah, this is that. Well, you have to make sure that the volume that you are using should be converted to dm cube. And how do you do that? You have to divide this by 1000. Draw the displayed formula. uh, okay, give me a moment. Acid C and D alcohol reacts to form a polyester. Draw the displayed formula of the repeat unit of a polyester. Okay, so basically, first of all, draw the acid over here, draw the alcohol over here. The alcohol acid is going to lose the OH, alcohol is going to lose the H, and yeah, then put the bracket, and that's going to give you the formula in short. So yeah, acid, alcohol, OH, H. This is the ester bond, and yeah, this is the repeat unit of it. So yeah, everyone, that brings us to the end of the paper. Have a great day. All the best. Thank you.